Hi everyone. This is a demonstration of Skytree 16.0 showing its main capabilities. We will use an example use case of predicting the income of a group of people. Before we show the use case, what are the main differentiators of Skytree? We believe there are three major advantages that Skytree brings to the user, both the expert and the non-expert alike. They are automation, speed and scalability, and ease of use. Other software has aspects of these, but only Skytree has all three. For automation, our AutoModel searches through the parameter space of multiple machine learning algorithms, and within each algorithm does a smart search through the hyperparameter space. This hones in on the best model much more quickly than a grid search, and finds models of an accuracy equal to or better than an expert user, while using much less user time. For speed, our benchmarks show that our algorithm implementations are faster than any others on the market, including command line libraries, normally only used by experts. These speedups are achieved by mathematical reformulation of the algorithms and not by approximations. For scalability, we have run our fully nonlinear machine learning algorithms, such as gradient boosted trees, on training sets of up to 1 trillion elements, 10 billion rows by 100 columns. The trends seen on the distributed computing system we used indicate that the software easily scales to even larger than this. For ease of use, all of our speed, scalability, and automation are available in our graphical user interface, so that the power and accuracy of our approach can be accessed in a few clicks. For expert users who want programmatic access via the SDK or command line, this is also available. Now that we have seen Skytree's differentiators, let's see our use case. In this business problem, a company wishes to use census data to predict people's income for marketing purposes. They would like to predict whether people earn less than or greater than $50,000 per year, and why. This will enable better and more targeted marketing efforts. We will build a supervised machine learning model to predict income for this company. This will be demonstrated via the Skytree Graphical User Interface, or GUI. To access Skytree, we log in with our user credentials. This gives us our main projects page, on which we can see a number of projects in progress that are solving different business problems. Click on the income project to access it. Within the project, a number of datasets are visible, including the raw data, data with an added ID, and the training and testing sets. For each dataset, we can view the data by clicking on its row entry and selecting data. This brings up a display of the data table. We see immediately the variety of different data types that are present: numbers, categories, discrete and continuous values. Skytree also handles text, time series, sparse data, and missing values. In these data, each row represents a customer, and each column is a piece of information or feature about them. Scrolling over to the rightmost columns, the column that we are shortly going to predict is the one labelled yearly income. This has two values: less than or equal to 50K, meaning that the person earns less than $50,000 per year, and greater than 50K, meaning that they earn more. We therefore have, for this use case, a binary classification problem. The data that we are viewing forms the ground truth for the problem, or training set. Skytree automatically holds out a portion of the data so that we can see how well our model generalizes. This is of course what we want when new data arrives after the model is put into production. On the Features tab, we see further information about the data that is of interest to the user. Here, each row represents a summary of the columns from the dataset on the previous screen. On the left are the column number, name, and data type. This is followed by whether or not the data are numerical or categorical, which is important for machine learning. Then there are thumbnails of the distribution of the data, dictionaries of values for categoricals, and some summary information about the distribution. Clicking on a histogram brings up a larger version for that column. This one shows the type of education that this person has. We can bring up others such as their marital status or gender. In each case, the total count and number of missing values are given on the right. A final useful histogram is the number of customers who earn less than or greater than $50,000 per year. We see that most earn less, but a significant number earn more. An improvement in accuracy of the models for predicting who earns less or more is therefore likely to bring in extra revenue for the company. Skytree also generates plots of the data. For example, clicking on SPLOM reveals the scatterplot matrix. One row at a time of the full matrix is shown, so we see, for example, a plot of other numerical columns versus the number of hours worked per week. Loading a new dataset into Skytree is easy. Navigate to the new dataset page. Give your dataset a name. Tell it the file location. Optionally specify column names, the separator, missing values, and select Preview. If the data are satisfactory, click Import to load the data. Data are by default loaded directly from the Hadoop HDFS file system, or the location of a local file can be specified, which results in the data being persisted to HDFS. Skytree does not attempt to load the entire dataset into the UI by default. If the data are very large, this will take a long time. Instead, a sample is loaded, and one can do what is called committing the dataset to indicate that when the machine learning is run on Hadoop, the full data are to be used. In this way, the UI experience is the same whether the data are small, as here, or very large. We now turn to our machine learning models. Skytree is designed to enable the easy and rapid creation of the most powerful machine learning models available, but also to give you full transparency and fine-grained control if desired. We are going to create a new machine learning model using the income training data to see how well we can predict whether our new unseen people have a low or high income. To measure the model performance, we of course need to know whether the people for whom we are predicting really do have a high income. To serve this purpose, we hold out a portion of the training data set so that we can assess the model against it. To create a new model, select New Model, select the data set to use, give the model a name or use the default, and select the column to predict. We are going to predict whether a person has a high income or not. This brings up the model specification page, allowing us to choose which machine learning method to run. Creating a powerful machine learning model in Skytree can be as simple as choosing AutoModel, which is shown as the default, and clicking Learn. We find in practice that such models are often competitive with the best efforts even of expert data scientists. However, say you do want to have more control, and there are many reasons why one might, then such control is available. For example, Model validation can be made more rigorous by selecting cross-validation. The testing objective can be one of a number of metrics as appropriate to the business problem. And we can set sampling seeds so that our model is reproducible. At the bottom right of the page, Skytree's automatic feature engineering is available. To enable this, simply check the box and run the model in the same way. Currently, the feature engineering is quite basic, but it will rapidly expand in future releases. AutoModel is also able to perform prerequisite transforms on the data, so that algorithms that require numerical data, such as support vector machine, can still be run even when the input dataset has non-numerical data, such as categorical variables or missing values. Finally, at the bottom of the page, we see that Skytree automatically calculates the amount of compute resources required for this job. For a Hadoop system, this is given in terms of yarn containers. This calculation means that users can use a full distributed system from the GUI without needing to know details about the memory, containers, and so on. Skytree automatically deals with this and does not exceed the resources allocated. Similar to setting parameters, there may be reason why, rather than AutoModel, one may wish to run a specific machine learning algorithm. This is enabled by selecting the algorithm and choosing which one you want, for example, gradient boosted decision trees. Here we see that full fine-grained control is available to the user. The parameters are tunable to new values. And if ranges or value lists are specified in combination with model validation. This tells Skytree to perform a grid search. Note that if one types an incorrect value, Skytree provides a warning. If instead of an exhaustive grid search, or if, say, you know you want a decision tree but do not know the best parameter settings, then it is possible to select our smart search, which will automatically navigate through the parameter space to find the best model, in many fewer steps than a grid search would take. Notice that many of the parameters that were not set to be searched before are now automatically searched over. As mentioned earlier, AutoModel also incorporates Smart Search. Finally, on this page, we see one of the options for model deployment with Skytree. The Predictive Model Markup Language, or PMML. To run our model, click Learn. In this demonstration, we have already run the machine learning model, so we can view the results. We see that 3 machine learning methods were run: gradient boosted trees, or GBT, generalized linear models, or GLMC, and support vector machines, or SVM. The best model in this case is the one with the highest Gini score, which is a measure of how well the low and high income classes have been predicted. Here, GBT is the better model, and it reached the best value on the 19th iteration. While both methods do work quite well, the algorithm concentrates on the superior GBT, while placing less emphasis on SVM. This shows the important point that AutoModel is much more sophisticated than simply running a set of models and choosing the best one. Note also that each point on the graph represents a complete machine learning run, with training and holdout set or cross-validation. If the user wishes to continue the search for some more iterations, Skytree has the option to continue training using the results found so far. The results of the model are available in tabular form in addition to graphical form, with the best model marked by a yellow star. Note that, for both the graph and the table, the results so far are available as the model is being run, and the user can watch the table being updated in real time. Moving on to the audit trail, this illustrates our project so far. The audit trail is a significant Skytree differentiator as part of our ease of use and enterprise-grade functionality, because, while other software can diagrammatically represent a data flow, Skytree is the only environment that combines the speed and scalability of advanced non-parametric machine learning methods to billions of rows, enterprise-grade software deployment, ease of use, and full documentation represented by the audit trail. Within the trail, the rectangles represent datasets, the rounded rectangles models, and the hexagons results. The trail has a number of uses, including keeping track of one's projects, returning to them after a period of absence, showing or passing the projects to peers, recording cumulative modeling experience and intelligence for the company, reporting to others, such as management, or for regulatory compliance. The right-hand side shows full details about each step of the process, including unique file identifiers and the full model and dataset information. Now, let's view some more details of our machine learning model results. Here, instead of AutoModel, we have run a grid search. The vertical axis represents how well the model has performed in generalizing to new data. Higher Gini is better. And the horizontal axis is the number of trees in the model. This is one of several decision tree parameters. We immediately see that the dark blue line, which represents a learning rate of 0.06 and a tree depth of 4, performs best, reaching the highest value at 100 trees. The user can filter the results to see the best models. The results here suggest that an even better model might be obtained with more trees than 100, because the performance on the unseen testing data is still improving. If the model began to overfit, the performance would decrease. Besides the GUI, Skytree has two other interfaces, a software development kit, or SDK, with language bindings in Python and Java, and a direct command line interface based on Unix shell commands. The GUI gives access to the full set of information that these interfaces provide via the model details, as we saw earlier, and the log file. We can view further details about the results of our model. The Results tab shows the application of our model, validated using holdout data from the training set to unseen data in the testing set. This shows, on the left, details such as the confusion matrix, and on the right, the ROC curve of true positives versus false positives. In this case, we can see that our model has generalized well to the new data. There is also the ability, if you can estimate the value of correct and incorrect predictions in your business problem, to give your model a dollar value by enabling our cost-benefit weighted evaluation. This gives a nice bottom line result of your model for its justification, or a succinct summary. If we wanted to apply our model to further data, we can use the predict and evaluate functionality within the UI. Or the model can be deployed by Skytree in production using its PMML output, or other options. Now that we have our model, and we have demonstrated that we can deploy it to new data, to close the circle and return to the question of income and what action to take for each person, we would like some insights. This visualization shows the Skytree decision tree machine learning model. Each data point comes in at the top and is propagated through the tree. In fact, Skytree has generated a whole ensemble of trees. But we will focus on the first one. The notion of which variables are the most important in the model, and hence why it is making the decisions that it is making, is measured by variable importances. Here, the higher the importance, the darker the tree node. For the example shown, the customer has a non-marital relationship, low capital gain but good education, and works less than 43 hours per week. The score value means that they are less likely to have an income of greater than $50,000 per year. In comparison, if they work more hours per week, the score now shows that they are more likely to earn more than 50,000. When we view the overall importances, we see an interesting story. While variables such as capital gain and occupation are predictors of income, as one might expect, the most important predictor of income is one's type of relationship. Thus, from this analysis, the model is telling you to give almost twice as much weight to people's relationship as any other variable, if you want to target people most likely to have high income. Of course, it is possible that different people have different reasons for earning the income that they do, and so Skytree enables importances not only for the model overall, but on a per-person basis. This then allows for follow-up tailored to each individual. If they have, for example, a non-marital relationship but a good occupation, and Skytree indicates that their income is likely to be high, then one would target the marketing to someone high income, but avoid sending material aimed at married people that someone unmarried is unlikely to respond to. Variable importances give the overall significance of variables in the whole model as one value. To gain additional insight, we can plot the partial dependence plots of variables. These show the effect of changing a variable with the effect of the other variables factored out. In the age example shown, this means that between 20 and 40, with other variables factored out, income on average rises due to age alone, then flattens out between 40 and 60. It then drops slightly, presumably due to retirement. The plot on the right, education, shows income rising as number of years of education increases. Plots can be shown for continuous or categorical variables and in 1 or 2 dimensions. In 2 dimensions, red means more likely to be higher income, and one can see the interaction between 2 variables. If the variables are of high importance, this is giving you even more insight into your model. For example, the middle plot on the bottom row is showing you that, regardless of occupation, husbands or wives are likely to have higher incomes. In conclusion to the business use case, we built a supervised machine learning model using Skytree to predict whether people earn less than or greater than $50,000 per year. The model classified about 85% of the people correctly. The most important reasons for income level are the type of relationship they are in, capital gain, and occupation. The probability of low or high income and the reasons given determine the most appropriate course of action for the company to market to each person. The customer wins from receiving better marketing. The business wins via more focused and successful marketing. And the business earns more money by deploying Skytree. Skytree has other features not shown in the income demonstration. These include create a test result dataset showing the predictions of a model applied to some data with the data alongside in the same file. This is useful for detailed analysis. Skytree has several deployment options, including the well-known Predictive Model Markup Language, or PMML, and our native binary format. The GUI allows you to export the model as either of these directly. The income example shown was a 2-class or binary classification. Many problems, however, involve multiple classes, and so Skytree allows this. Rather than the 2x2 confusion matrix we saw earlier, multi-class results in the larger matrix seen here. For multi-class, some metrics such as Gini are not defined, so we show the model accuracy. Regression models can also be built with Skytree. Skytree includes text analysis capability in the UI and the ability to read many different text file formats. We allow, for example, the term frequency binomial separation, or TFBNS, which is known for many problems to be superior to the more widely used term frequency inverse document frequency, or TF-IDF. Finally, as part of our end-to-end data science platform, we allow arbitrary data preparation at scale using transform snippets, which can be previewed or run. The preview adds interactivity to the analysis, and snippets the flexibility for the user to fully solve real-world machine learning problems. If a snippet you desire is not available, you can define your own. Aside from the graphical interface that has been the focus of this video, Skytree allows the user to work programmatically. The Python Software Development Kit, or SDK, allows the user to write their project in Python, hence the Jupyter notebook shown, which when executed is the equivalent to running the project seen in the GUI. It is also possible to access the API directly via its calls, which means that other SDKs in other languages can also be developed, or that Skytree can be integrated into one's existing application. The SDK also allows you to define your own transform snippets using only the SDK binding language, such as Python, and not requiring the user to know the system we use for distributed data preparation, the well-known Spark. Furthermore, users who only use the graphical interface have access to any snippet that has been defined and shared, so they can instantiate arbitrary data flows at scale without any coding. Skytree can also be accessed directly via the command line, which means that any software that can call the command line can call Skytree. The example shown is a bash shell script. The command line also means that Skytree can be installed and run without requiring Hadoop, which is a requirement of the GUI and SDK interfaces. All of the interfaces, GUI, SDK, API, and command line, all ultimately access the same powerful underlying machine learning algorithms, and all of them gain the power of their computational speed. Finally, as well as running on your own computer or in-house system, Skytree is also available on the cloud via Amazon Web Services. In particular, we have a process called elastic machine learning, which allows a job to expand onto more machines if it turns out more computational resources are needed, within limits defined by the user, of course. To conclude, we saw a business use case, and now we reiterate Skytree's main differentiators: automation, speed and scalability, and ease of use. Most important of all, and our greatest differentiator, is that we combine all three of these into one system. Thanks for watching, and we hope you enjoy using Skytree.